All right, so what you guys were supposed to discover, like I said, is something that we talked about before, and that is that there's a relationship between the proportions of the sides of two shapes, whether they be polygons or whether they be circles, and the area of those shapes, as long as the shapes are similar. Okay? So as long as all of the sides are in the same proportion, then this is going to hold true. And so, bless you, what you're supposed to discover is called the proportional areas conjecture. And so when you drew a rectangle and then you multiplied it by the scale factor that you just randomly picked, how did the areas of the two rectangles relate to the scale factor that you chose? Mackenzie. So what was your scale factor? 2, and your area was 4. What? You said double.
The ratio to the area.
What was the ratio between the areas?
2 to 1 and 4.
Right, okay, so she said that when they, I think that's what you're saying, is that the sides were in a ratio of 2 to 1, is that right? Okay, and then the areas were in a ratio of 4 to 1. So she's saying that the ratio of the areas was twice as much as the ratio of the sides. Did anybody come up with something different? Anybody come up with something different? Did you use a different scale factor than 2?
It's squared.
It's squared? Okay, so because of these numbers, 2 to 1 and 4 to 1, we could go one of two ways with it. And that's the fun thing about the number 2. In case you're curious, what's so fun about the number 2? Now you know if you double it and if you square it, you get the same answer. So the question is, if you double the sides, the areas will be 4 times as big, but is that because you take the ratio of the sides and double it? Or is that because you take the ratio of the sides and you square it? And so what I'm looking for is another group that used the ratio in the rectangles that was not 2. Is there any? Yes. Okay, and what did you come up with for the ratio of your areas?
Ratio of the area.
Uh-huh.
9.
9. Okay, so let's look at this other one, and this will help us decide it. For them, the ratio of their sides was 3 to 1, and the ratio of the areas was 9 to 1. So is it that the area is doubled or the area is squared?
Squared.
It's squared because that's the only one that fits for both of these cases. 2 squared is 4, 3 squared is 9. So if you took your original rectangle and you made all the sides 4 times bigger, then the area would be how much bigger?
4 times.
16, because 4 squared is 16. And so what they're saying here in the proportional areas conjecture is that if corresponding side lengths of 2 similar polygons or the radii of 2 circles compare in the ratio of m to n. And so they're saying, let's not limit ourselves to 2 to 1 or 3 to 1. Let's say maybe we took it and multiplied it by 3/2. Or by 4/5. Okay? So any fraction here will work. Then their areas compare in the ratio of what? What is our final answer here? What do I do with the ratio to the sides to get the ratio of the areas?
Double it.
Square it. So my area ratios would be m squared to n squared. Okay? You guys seem maybe a little bit befuddled, so we'll do an example before I turn you loose. Yes?
So if I say hi mom to that thing and that shows my mom, she hear it?
Yep. If you show it to your mom, then she will hear our conversation right then.
Oh, hi mom.
But How will she know it's you?
Because
And why in the world would she want to sit through this
she makes
boring
me watch,
geometry
because she
video?
makes me watch these. And one time Stacy said hi to me, and then I saw it, and then she goes, yeah,
Stacy sits at my desk,
yeah, she saw me.
and so she's on these a lot. She's pretty much famous. I looked over her spring break, really close to going viral. I've got probably like 12 or 15 videos now, and I added them all up. I've got like 250 views, so I'm on the edge. Almost there, yeah. Any day now.
What do they consider when you go viral?
Like a million or something. Not even close. Not even close. Okay, so let's do an example that maybe will help you understand this a little bit more. So, for example, if you need okay, so let's take a look at one here. Let's do an example with some cheese and some pizza. Okay? So let's say, for whatever reason, you need 3 ounces of cheese for a pizza with a diameter of 12 inches. When you are putting cheese on a pizza, what characteristic of the pizza determines how much cheese you need? How big it is, the circumference, the area, the radius, the what? The diameter, which one of those things? The area, right. You're covering the pizza with cheese. So you're covering the entire area, the surface area of the pizza with cheese, okay? So, what's the formula for the area of a circle? Pi r squared. So do I care that the diameter is 12 inches?
Yeah.
What do I really care about though? The radius is what's going to determine my area, and the radius is going to be 6. Okay? What is the radius of my new pizza, which has a diameter of 16? That now has a radius of 8. Okay? So what I need to do in order to figure out how much cheese I need to cover my new pizza is I need to set up a proportion. Okay? So I need to say a radius of 6 over a radius of 8 equals 3 ounces over I don't know how many ounces. All right? Except that since we're talking about area, what do I have to do with this proportion right here? I have to square, okay? And I'd like to kind of reduce it first. Can I reduce it first? No?
Sure.
Please?
Yes.
Okay, thank you. Hannah, you're forgiven for not saying that immediately. Just yesterday, I think, Easter and everything. So 6 over 8 reduces to what? 3 over 4, okay? So the ratio of the radii of the 2 pizzas is, really? Is
really?
Okay. Is 3 over 4. But again, since we're dealing with area here, I am not going to go 4 times 3 and then divide it by 3. What do I have to do with this first? I have to square it. Okay? Now, squaring fractions sometimes strikes fear in the heart of high school students. Right. All you have to do is just square each number. So 3 squared is 9. 4 squared is 16. And that's going to equal 3 over x. And now how do I solve that? What 2 numbers do I multiply? 16 times 3. Very good, Madison Studer.
5.3.
So 13 times 6 is 48. And then what do I do after that? Divide by 9. Very good, Madison Studer.
5.3.
And what do you get? 5.3 repeating?
Yeah.
Okay, so you would need about 5.3 repeating ounces or 5 1/3 ounces of cheese for your bigger pizza. And you can see, yes?
If the measurement if you want to just round it up.
Probably, but I mean, let's just pretend that you're like a Domino's pizza guy or something, and you're talking about ordering enough cheese for 1,000 pizzas. Then you're just going to go with, and they do actually have a little scale in there. If you ever go in there
Yeah.
and they're making the pizza, they throw some cheese or pepperoni or whatever it is, they weigh it before they put it on because they kind of want to quality control that whole thing. Okay. Okay. So the moral of this story is, if you didn't understand this whole idea about area, the ratio being squared, then you would start from this very first thing here, and you would say, well, I have a 6-inch radius by an 8-inch radius over, and that's 3 ounces, and I need to figure this out, and you would totally screw that up. And you would say that I only need 4 ounces of cheese for each one of those pizzas. And then you would either run out of cheese, or you would have some really bad pizzas.
How'd that be bad?
If you only have like a little bit of cheese on it, I hate that. Like when you can see the sauce through there, you want like a layer.
You want a smooth layer. Yeah.
Crispy, greasy, cheesy. Okay?
Okay, you sounded like the commercial of CoverGirl.
Cover girl.
Breezy, beautiful cover girl.
None of the fly.